Right, welcome everybody. My name's Steve Morris. I work for the Knowledge Transfer Network, and also as a part of my role, I have responsibility for working for the Energy Harvesting Special Interest Group. Webinar has been organized by the Energy Harvesting Special Interest Group to look at the upcoming energy harvesting call and to consider the design option, which is a part of, potentially a part of all CSB calls. So if I can just tell you a little about the Energy Harvesting Special Interest Group. It's all about supply chain successfully to market really haven't emerged in the UK. And so far, developments of the energy harvesting components and devices are limited to just a handful of SMEs. But the Energy Harvesting Special Interest Group is going to assist in the direction of funding of R&D to improve the understanding of the applications domain opportunities for energy harvesting, improve dissemination, state-of-the-art, support emergencies of the emergence of supply chains, and raise awareness of the UK and wider European capabilities in energy harvesting itself. The KTN, the Knowledge Transfer Network, is a new company set up by the Technology Strategy Board, which started operating at the beginning of April. It encompasses the 16 knowledge transfer networks that were originally working independently, brought them under one company, called the Knowledge Transfer Network. But that continues to be enable collaboration, and really we're here to facilitate collaborations between industry and academia to move forward innovation in various areas. My interest is materials, but across the spectrum. So the KTN itself is an independent body. It's impartial. It's professional. People coming from business and moved into this sector. People who are knowledgeable in their areas and who are connected to various networks that are relevant to the work they're doing. So I'd now like to pass across to Mervyn Jones, who's going to tell you a little bit about the energy harvesting call. Mervyn.
Okay. Good morning, everybody. My name is Mervyn Jones. I'm lead technologist at the Technology Strategy Board for Electronic Sensing and Photonics. This competition opened yesterday. This is a competition on energy harvesting for autonomous electronics. And in fact, this competition follows on a feasibility study that we did about months ago. So what I want to do is to tell you about the competition and also about introduce the design option, which will be further covered by some colleagues. So let me just find the mouse here while I look. Yeah, what I need to do is find the mouse. Where is the mouse? Sorry? It's on that screen. I see, sorry. Okay, so excuse me while I move on. So this competition is a £2.5 million competition for collaborative R&D and looking at projects that take, the expected outcome of the project will be demonstrators demonstrating the use of low-power energy harvesting to drive electronic systems, for instance, sensor systems, wireless connections. So energy harvesting, scavenging of energy from the environment, from the surrounding environment, and converting that into usable electrical energy. And this might be in order to extend the life of batteries, of rechargeable batteries, or indeed to replace batteries altogether in equipment. So looking at the competition itself, it's single stage, so it's nice and quick for you as an applicant. The project, as all TSB competitions, needs to be led by a company. And when we say collaborative, we mean you plus at least one other partner. The other partner could be a company, could be a research organization or a university. And we're quite happy for small companies as well as large companies to lead on projects. and we in fact encourage small companies who are usually very dynamic and have great ideas to be parts of projects. So the total available is 2.5 million, and we're looking at projects in the range of 300k to 500k pounds. So that's the project size in terms of eligible costs. As a company, if you're a large company with more than 250 employees, you would be eligible for a grant of 50%. As an SME, is 50%. And we expect projects to last 30 months. The application process is fairly straightforward. It's an application form consisting of 10 standard TSB questions. So that's the competition overview. Key dates: the competition is already open this week, yesterday. We will have a briefing event in London, a live briefing event in London on the 9th of June, so that's next week, next Monday. I encourage you to sign on for that event, and I'll give you the link later on. We also have key closure dates, and the key submission date is the 25th of September, so you've got quite a bit of time. But remember, that will cover the summer period, so you need to make sure that you've lined up your project and your potential partners well before that time. And the deadline for registration is the 18th, the week before. Looking at the design option, the topic of today's summary, the design option is already open, and the submission, if you like, or registration of interest for the design option will close on the 4th of July, but that's a very straightforward process which we'll touch on in a minute. Everything that you need to find about this competition is already online, so if you go to the TSB competitions page under Energy Harvesting Autonomous Electronics, you'll find this page, and down the right-hand side are all the links that you need for this competition, including, for instance, guidance for applicants, the scope document, and key for today's presentation are links to the design option. So make sure that you click on those links because they include guidance for how to apply for the design option. But in summary, you apply for the design option as follows. You need to send an email to designoption@tsb.gov.uk. So a simple email. The subject line is DO, design option, request, EH, and your company name. So that's the title of the email. And then in the body of the email, give the following information. And it's about your organization, who you are, who your organization is. And we expect lead applicants or potential lead applicants to apply or register for interest in the design option. And in no more than 500 words, tell us about the potential project and your interest in the design option. And we'll take it from there. First come, first serve, provided you're in scope with your potential project. So we're looking to allocate 20 design projects for this particular. And remember, this is an option. You may apply for the design option and then later on not apply for the main competition. So that's perfectly fine. You may also apply for the main competition and not apply for the design option because actually you're rather good at the design option already. Jim will tell you a little bit more about the design option in a few minutes and what it gives you. But I think that I'm going to stop at that point and link to the following additional information. So the main page is, you can get that through innovateuk.org and then funding competitions. Steve earlier told you about the special interest group, and the special interest group link is also shown on here. Go on there and link up with other companies who are active in the energy harvesting field. And the final point is, please come along to the briefing event on the 9th. You can register for that event, also from the main competition page, energy harvesting competition page. So I think that's well it from me. So that gives you an overview of the competition and the key dates. Now I'll pass to Jim Dalton, who's going to tell you specifically about the design options.
Good morning, everyone. I think there may be some notes to say that the sound quality is not very good. I'm just going to try to pick up the handset at this end, and we'll see if it sounds any better. So anyone listening to me at the moment, if you could just send a note to give us some reassurance that the sound quality is better if I do this, that would be incredibly reassuring, because it is most bizarre sitting in a room talking to nobody. So let me move forward. So there's a little bit of crossover this morning. I've been asked to talk about design options. So my name is Jim Dalton. I'm here with a colleague, Ben Griffin, and we're actually handing over the role of lead specialist design at the Technology Strategy Board. And it's something that we've been really working on within the Technology Strategy Board, i.e. the context of where design fits into the sort of technology-enabled innovation that we support. And the design option is very much part of that. So, again, just moving forward. In some respects, what we've been doing is trying to look at two occasionally opposing forces within the innovation process. The role of technology and the role of design. Technology historically sits very comfortably within R&D within businesses, design more so in the marketing side of the business. I'm just going to hold here a minute. There seems to be a bit of activity. Let me find out what's going on. Hold on a minute. Are we okay?
A lot of echo. Way too much echo.
Just bear with us a moment. Right, we're doing a little bit of manoeuvring. We'll see how it goes. I'll press on, so forgive us for that. The only problem is my screen has now been turned around completely in the room, which means I can't see a thing. We're fine. Let's just press on. So, as mentioned, we're looking at the combination of design and technology, sometimes opposing forces, sometimes beautifully aligned. And it's our belief at the Technology Strategy Board that if we can align those activities at a quality level early in the R&D process, then we believe it can lead to better commercial success. The reason why we're interested in that is, as the Technology Strategy Board, it's our remit to effectively grow UK GDP through technology-enabled innovation, and we believe that good design used early will improve the likelihood of commercial success, and therefore we have a responsibility for return on investment in public sector funding. So, built around that philosophy, we've been piloting something at the moment, which arguably has been quite a long pilot, and there's various reasons for that, not least because it takes a while to set these things up in the context of the normal competition modes. But we've been piloting something which, in the context of this competition, applies before competition applications. We've done it on two-phase competitions before, so it's slightly different if you're aware of it from that context. And basically, before the full competition application, which Mervyn's already mentioned, I think it's in September, we're offering, quite simply, 2 days of free, I hesitate to use the word advice, but not least because there's issues about what we can advise on and can't advise on. But in essence, 2 days of free advice on the role of design, and very specifically design, on bottom line return. And so that, in essence, is what the design option is. Now, one of the important things is, and as you're looking at your screen, don't be worried, this is not a problem with your computer. What we are saying is that we believe design should happen at the point when you're loading your project. And in the context of the funding from the Technology Strategy Board, that loading is happening now. The application is September, you're making plans, and it's our belief that those plans should include the consideration of where design fits in. Not least because you'll all be very familiar with these sorts of diagrams about the innovation journey. By the way, you've probably worked out by now that all of my images are sort of Google screenshots that I drop in. I claim no copyright on any of them, and I hope I don't upset or infringe equally in the other direction. So you'll be familiar with the innovation journey that looks a bit like this. And you can imagine with the right-hand image, if we apply design right at the end of that journey, i.e. when the line straightens up, then it's going to have little effect on the actual core innovation development. So it's our belief that design earlier on in that squiggle will have benefits in terms of not achieving the left-hand straight line, because I don't think any of us have ever experienced that, but hopefully reducing the number of twists and turns on that innovation journey. So that, in essence, is where we're going. Just a slight digression, and as I mentioned, I get these images off Google. I think it's fascinating that the top two images, or actually the second in at the top and then the one below, have got exactly the same squiggles with slightly different writing on. So the problem with these sorts of diagrams is everyone actually follows the diagram rather than reality. But in essence, oh, and I also wish that man leaping over the two cliffs and the sunset, I wish that was the reality of the Valley of Death, but of course it isn't. So we recognise a lot of these things. Oh yes, and the final thing is that this picture shows you that you don't get success right first every time, because they put a spelling mistake in. Slight digression. Now, I suspect the audience this morning is split, hopefully fairly evenly, between a very design-savvy audience, maybe some designers listening in. It's great to have you on board, as it were, of this webinar. We're also recording this, and we're going to play it to wider audiences over the next few weeks. The other half of the audience, I suspect, are the technology developers, people who have been sort of pushing the boundaries of science and technology, looking for opportunities in the context of energy harvesting. And I guess this next sort of chunk is a little bit more towards that latter part of the audience. So for those designers amongst the audience, forgive me for maybe going over some ground that you're very comfortable with. At the Technology Strategy Board, we very simply buy into the fact that design really covers three elements. One is desirability. And desirability is really easy, isn't it? We all knew that that's the car that somebody desires. And in essence, that highlights the problem. The problem is what is desirable and for whom. And you can develop some technology a long way down the innovation journey and then realize that it may well work very well, but it's not really what somebody wants or is attracted to. So understanding your users, your audience, your customers, your market at that early stage should reduce the numbers of loops back towards the end as you get nearer to market. To highlight the problem, if you Google good-looking car or something equivalent to that, you get something like this, including a shoe. I'm not quite sure why there's a shoe, but it's a lovely example of the challenges of desirability and the need to understand your market. The other aspect of design that we think is a core component is usability. And arguably, the designer is the champion or the expert of these two elements. And whereas perhaps we think desirability is a little bit of an obvious challenge to address, usability, in my experience, most people think that they kind of get that bit. We all understand what works and what doesn't work. And in fact, when you Google usability, you end up with caricatures because it's so difficult to explain why usability is actually a challenge. If usability is not really a challenge, then why do these guys look so worried? That was probably about a year old now, maybe a bit longer. That's at the launch of the IS platform for the mobile. And you'll recognize most of those guys. And Johnny Ive looks absolutely petrified because he doesn't know what somebody's going to do with that interface. And that is all about usability. So the combination of those two elements, desirability and usability, are key components of market success. And we believe designers are the expert of that space. Because you just can't predict what people are going to do. Nobody would imagine that people would buy an accessory to wear their smartphone outside their pocket on the front of the Luke. The third element that we believe design covers is feasibility. However, we don't believe it's actually the expertise of the designer. We believe that actually businesses, technology companies, engineers, arguably are the experts of feasibility. And we're pretty comfortable actually with our audience at the Technology Strategy Board that if we ask for a bridge, the bridge gets built and it doesn't fall down. And we believe in many respects that's your domain, not the domain of design. However, I think there is a responsibility for the designer to challenge feasibility and to do that in the context of the delivery of the former two. Because basically, and again, don't worry, this is not a fault on your screen. If people have to wait too long, then it just doesn't work. And we all know the frustration. We all know how quickly we will walk away from something that just doesn't satisfy us in that respect. And that's feasibility, and it's actually a problem for everyone, not just those people who would more recognise to have that problem. That said, or all of that said, we at the Technology Strategy Board don't actually believe that design will save the world. We believe it is a component of technology innovation, but it's not going to solve every problem. It's not going to solve every problem, but we do think it's important. And this image beautifully illustrates, in a sense, on paper, from an engineering, from a feasibility context, this is wonderful. You can fit 2 urinals into a very small space. The gentlemen amongst the audience will know that we very rarely actually stand next to each other in the men's toilet unless it's very, very busy. So this one is just a no-go. And the problem is, from a business context, from a commercialization context, which is our interest in the Technology Strategy Board, is that whoever built this has paid for 2 urinals, and they're also paying for the cleaning of 2 urinals, because one person will use one time and then another time. So actually, misunderstanding what is actually desirable and usable is having commercial implications, and that's at the heart of what we're trying to do with this design option, is to get those companies that aren't really aware of what design is and how it works in the context of technology R&D. We're just trying to open eyes to that fact. And maybe a bit of a takeaway to help with that, I often use this sort of metaphor for the role of design. So this is our outcome. This is a lovely loaf of bread that we see in Greg's the baker or something. You're not supposed to squeeze it, but you do. And it's got that crunch on the outside and the softness on the inside. Absolutely fantastic. You buy it. The raw materials for that and the process for that, well, we're pretty familiar with. Again, just a Google image. And if you like, if you can go with me on the metaphor, design is the yeast in the front of the picture. In fact, yeast is so small, they've actually put a whole box of it in the picture, but you don't really need much of it. So it's a small ingredient, but a very important ingredient. It's also important to have good quality design, and you can very easily have dead yeast that will have no effect. But imagine, and go with me on this, imagine you make the loaf of bread and you just don't put the yeast in. You don't put the design in. You still end up with a loaf of bread. Technically, you've achieved the task. You could put that on the shelf in Greg's, but if you do squeeze it, you're not going to be inspired to buy it. And if you kind of miss that point and you do buy it and then you use it, you may end up at the dentist. So, and all it is the missing ingredient. Now, it's often encouraged to use design, and one of the challenges is that design sometimes gets left too late. And this Google image is a bit of a weak one because I couldn't get sprinkling yeast on the end of the bread making process, so this is the best I could come up with. And a little bit like the toilets, if you sprinkle design on the end of your project, it will have limited effect, if not none at all. If you sprinkle yeast on the end of your dough making and pop it in the oven, it won't have any impact. If not, it may make it worse. And like the urinals, you've paid for the yeast and you've added the process. So the core thing is to use good quality yeast early in the bread making process. It has its effect, quite subtle, it has an effect in the rising of the dough, it has an effect when it's in the oven. And it's a metaphor for what we believe design can do in technology-enabled innovation. Get design in there, a small ingredient, good quality, use it throughout the journey, and it will do things that you almost don't notice, but it has a significant impact. And Bob's your uncle, that's where you make your money. So it's our job with the design option basically to inspire companies that are considering applying for the energy harvesting competition, inspire them about the impact of design on bottom line. And this is now slightly old data, so forgive me for that, but it just illustrates a point. Basically, this is an index of some companies. Design Council did it a few years ago now. Of course, these are big headline companies. We would love a similar sort of page with a lot of SMEs, a lot of startup companies with great stories to tell, and they're emerging, and so we'll build on that. But basically, as you can see, old data but relevant, that basically a design index of companies that's said to be design-led against the FTSE 100. If you invested £1,000 over a 10-year period, you get £500 back as opposed to £3,000 back for the design-led companies. So that's the impact. Just a reminder from what Mervyn was saying that this is for companies that are thinking of applying. As the Technology Strategy Board, we can only fund companies, so you've got to be a potential lead on the competition. If you are, you can apply. You can go to some of the links you saw. You can just Google Technology Strategy Board. You can Google on there energy harvesting design option. You'll probably get a page that looks pretty much like that. And on there will be a link to a very simple Word document that highlights basically what I've been saying, what Mervyn's been saying about the sort of way we stack this up and what we can do and what we can't do with the design option. The important thing to stress, Mervyn mentioned it, is his optional, which is why we're calling it the design option. And at that point, I'll hand over.
Hello, this is Steve Morris again. I'm just handing over to James Auger now. James works at the Royal College of Art, and James has been very active in working with technology people from Imperial College in London, and I thought it might be useful to get a perspective on what he brings to some of the technology projects. Okay, James.
Hello. Hi, everybody. And thanks for the introduction. So I think I'm going to reiterate some of the points that Jim made along the way. We're both talking about design, so that there will be a couple of overlaps. But specifically my work and the work that we do at the Royal College of Art in the programme of design interactions is looking a little bit at what we call domestication of technology. I'm going to go back to one of my favourite designers, and apologies for the people with a design background here. I don't want to talk about what you do yourselves. This is more for the non-design people. I'll go back to Charles Eames, who in the 20th century said, design is a plan for arranging elements to accomplish a particular purpose. So the key bit of this phrase that I want to talk about a little bit is the elements. So in the mid-20th century, what Charles Eames would have been talking about really are the types of materials you see here. You're talking about fiberglass, the lamination of plywood, which he was borrowing from the airplane industry post-World War II, and arranging these to create these desirable pieces of furniture. The Eames were particularly skillful at this, so these became design classics. They're still around today. So their arrangement was done in a particularly designerly way. Shifting forward to what we're doing, and this is where the science and technology comes in. The elements that we're arranging are done in collaboration with a lot of academic institutions across the UK and institutions such as Microsoft, Intel and so on. And we're really looking at emerging technologies. So how the technologies that are in the laboratory stage today could effectively be developed to impact life in the very near future. So we work with the scientists and technologists to inform this speculative process. And this is where the idea of domestication comes in. So we find this interesting because what it represents really is a shift of habitat. So here you have the wolf in its natural biotic environment, basically adhering to the rules of that environment, the rules of survival. And here you have a 15,000-year process where through artificial selection, that wolf has been transformed into the domestic dog. And looking back at Jim's slides of all of those cars, those diverse range of cars that talk about human desire, here this dog talks really about the idiosyncrasies and the nuances and the complexities of human desire. And I think designers are perfectly placed to start both understanding these, but also kind of creating them and manipulating them. There's an example of this. This effectively could be seen as the domestication of computer technology. So the image on the left-hand side is from Cambridge University in about 1951. Obviously, the computer had a history going back to Babbage around 150 years before that. Design played no part in the development of the computer until arguably the early 1970s, late 1960s, where there was this shift to try and bring this technology into the home, into domestic life. Shift forward another nearly 50 years or so, you have the Apple iMac on the right-hand side. And here you can see the role of the designer in really shaping the form, the aesthetics of the product, the way we interact with it through graphic user interface, mice, these kind of things. And also the function, so the shift of the computer away from office tasks to the internet, and the development of all of the apps and the various programs that we use to really manipulate and mediate all aspects of life, communication, purchasing, arranging our media such as photographs and so on. Designer, obviously through Apple, we saw the picture of Johnny Ive earlier on, extremely influential in domestication and the success of this particular form of technology. A little bit of a graph, I don't know if this is clear enough to see here, but this talks about the two forms of process that we're doing. So you could imagine here on the left-hand side are the technologies that are emerging at the moment, very much in the laboratory space or in the offices of the people developing the technologies, not really informed or influenced by everyday life at all. And through this process, what I'm calling domestication, entering everyday life, which is the horizontal graph. And we could imagine that each product is iterated through developments in technology over time to lead to the next product on the marketplace. We can speculate by looking at emerging technology at what the future products of tomorrow might be like. And this is where we think design comes in. Again, it's sort of backing up what Jim was saying. It's really moving design upstream to introduce the idea of the design, or the idea of the aesthetics and interactions and all of the other things that make products saleable much earlier in the developmental process. There's another thing that we're doing as a strategy, which is stepping out of this lineage at some poignant time in the past to imagine alternative presence. And this is looking at how technologies that were neglected or not used in the past, that didn't become popular or mainstream, could be brought back to life, and what kind of present we'd have as a result of those things being developed. I'm just going to run through very quickly a couple of examples. This is an early project that we did along these lines. It's called the Audio Tooth Implant. So it's the idea of a telephone being implanted in the tooth during routine dental surgery. This is the kind of habitat or that lineage that I was talking about a moment ago. So going all the way back to the telephone box, the telephone then entering the home through the hardwired device, and then jumping forward to the mobile phone. Telephones becoming portable and carried with us at all times. Bearing in mind this project was done around 2001, we hadn't had smartphones at this time. That might have influenced the next step for us. But here, we're imagining the next logical step for the telephone could be it becomes part of us, it enters our body. Working with the technologists here, we worked with engineers from British Telecom to talk a lot about the technology that would make this happen. So we were talking about micro piezoelectrics, near-field magnetic effects, dormant chips in the tooth, various different forms of technology that would make this both plausible and believable to the everyday audience. And it worked as a sort of strategy for thinking about potential communications futures. This is a genuine scan of United States Time magazine, and you can see on the top corner we were invented as one of the coolest inventions of 2002. So this gives us a flavour of what type of futures we might have as a result of design and technology coming together. This is an example of the alternative presence I talked about. It's used a lot in literature. So this is from Philip K. Dick, and it's a classic story of Germany and Japan winning World War II and what life might be like. This is here the story plays out in the 1960s. But I wanted to steer the discussion onto this idea of energy. Obviously, it's the theme of today's event. This is from Sasha Poflep, who imagined a different outcome to the 1980 United States general election. And Jimmy Carter, who had lots of green energy initiatives, won the election. As we know, Ronald Reagan won it and cancelled all of the green energy research taking place in the States. In Sasha Poflep's alternative presence, Jimmy Carter won, and all of the research that was taking place in the 1980s continued to today. And you end up with an extremely different landscape in the United States that's very energy friendly. Another thing that we're interested in, this is a brief that we ran at the Royal College of Art, imagining that Nikola Tesla never existed. So without Tesla, you get no alternating current. Without alternating current, there are no power stations delivering energy to all of our houses. And the energy generation techniques being developed at the turn of the last century might have had 100 years of research going into them. So what kind of products, what kind of systems for generating energy might we have today? This is just an image from the 1950s Ford Corporation, where they were imagining a nuclear-powered car. One final couple of points that we're interested in. So design for us is not just about the products that sit with us in our homes, sort of small portable devices. We're much more interested in the infrastructures as well, so how landscapes change as a result of developments of certain technologies. So here's just a few classic examples of energy in the Industrial Revolution, where water obviously influenced landscapes. In Holland, you have the windmills, energy really dictating and defining how the landscape looks. I don't know, is John there? Is there any way that John can chip in? Because I was representing Design Interactions. We also have Dr. John Stevens, who's from Industrial Design Engineering, another department at the RCA with a slightly different strategy. John was going to talk over a couple of their projects, but I don't know if it's going to be possible to get him online. John? No? Okay. I'll quickly try and describe his slides for him, which might be tricky, but I'll do my best. He's saying that innovation design engineering is essentially about marrying technology through engineering with design at the outset of any project. He gives us a couple of examples. So this is Design to Win. It's a student project by Luke Fasaro, and it's exploring the capabilities of emerging rapid manufacture. The project is a response to the challenge from an elite athlete to shave a hundredth of a second from a 100-meter sprint. And the design here is addressing the psychological dimensions of elite athletic performance. The runner must believe in the shoe. It must visually and physically embody victory. Sorry about this. I wasn't quite prepared to talk about these. So, okay, there's a couple of other projects. He's talking about this Airbus thing that they're working on in IDE at the moment, which is about the future of air travel. And it's talking about Airbus came to IDE to explore the future of air travel, which is unsustainable for many reasons. Looking at around 2050, the current rate of production will need more, all of those aluminium just for planes. I'm going to quickly whiz through these. This is another project which is looking at biometric technology and new forms of digital cameras. And I think the last slide here would be some of the people that IDE are working with as part of their design research. So, sorry that it got a bit woolly at the end there. I wasn't quite prepared to talk about those slides, but I believe that's it for me. So I'll pass back to Steve.
Okay, everybody. Well, I hope that we overcame some of the sound problems that there were earlier. Just to let you know that we have recorded this session. So all of it is recorded with the pictures. We will be making those available in due course. They will certainly be available on Underscore Connect, probably under the Materials Community and under the Energy Harvesting Special Interest Group. And we will also try to find some outlets into the design community. RCA is an obvious one because James is here. And we'll look for some other ways to do that too. For all of those of you who have been a part of the webinar today, we will of course send you a link to the video when it's available. So really at this point we would like to ask you if you have any questions, if you'd like to type them into the chat box. What we'll do is we'll pass the phone round to the appropriate person to answer the question. So I'll stand here until Aileen tells me that somebody's asked a question and we can seek an answer. So has anybody got any questions? Has anybody typed anything yet? Does that mean we've blinded you all with science? Or design? Or both? Or the microphone's not working and nobody can hear me? I'm hoping that's not the case. Otherwise... Has nobody got any questions then? Well, if nobody has any questions. I think we're going to bring the webinar to a close. As I say, we will send you all an email to people who've been on here with a link to that video when it's available. and I'm sure that we'll be appearing in due course in various events that Moby's going to be running on the call, the launch of the call, which I believe the first one is in Cardiff on Thursday, and then the one in London is on the 9th, and the one in Glasgow is on the 18th of June. And I'm looking forward to hopefully seeing some of the designers who've been on the line today at some of those events and taking the opportunity to talk to the technologists who will obviously be thinking about what projects they might bring forward into that call. And if you get to talk to them, hopefully you might get involved in the project at the early stage, which is what we've been discussing today. So I'd like to thank you all for taking part, for listening, and hopefully we'll see more of you working together in the future. Thanks very much.